Fermilab, one of the most famous, if not the most famous national lab in the United States, is in trouble. We have known this for some time, and I talked about this previously. New is that a group of Fermilab employees who refer to themselves as whistleblowers have aired their grievances by publishing a report on the archive. I've had a look. Fermilab was home of the Tevatron, the world's largest particle collider, until the Large Hadron Collider went online. The experimental collaborations at Fermilab's Tevatron discovered the top quark, that's the heaviest of the quarks, in 1995. Their newest flagship project is DUNE, the deep underground neutrino experiment currently under construction at Fermilab. Its task is to shoot a beam of neutrinos through Earth's crust from Fermilab to Sanford Lab in South Dakota, about 1,300 kilometers away. With that, particle physicists want to learn more about neutrinos, especially their role in CP violation. But DUNE has become a major headache for Fermilab. The management has been miserable and the cost has spiraled out of control. DUNE was originally proposed with a cost projection of about $1 billion, but kept getting more expensive. The Department of Energy put a cap on $3.1 billion. Fermilab got a new director, a bad grade from the DOE, and a new management. If the budget cap remains, that'd mean that the project has to be scaled down so much that it won't be able to measure the CP violation before 2035 or so, at which point other experiments might have measured it. An article that just appeared in Science details that the financial problems at Fermilab are worse than expected. They've simply run out of money and can't pay staff, so for the last week of August everyone will have to take vacation or go on unpaid leave. And that isn't it. The whistleblower report tells a few inside stories that are, well, interesting. A lot of the complaints circle around an employee by the name of Randy. After working with him, he went to DJ's office and told him that I was too dumb to work there and that the only reason I got the job was because I was a woman and I was Latina. The same employee evidently also brags about having a loaded gun on Fermilab's site and has claimed to several employees that he killed a transgender prostitute abroad. Then there's a guy called Dave who tried to crush a woman with a truck. The female witness had been repeatedly harassed by peer electrician Dave. The latter became obsessed with her, and in spring of 2022 he backed a £25,000 bucket truck at her and another peer in the parking lot near Lab A. She and her peer were nearly crushed. Interesting colleagues you got there. Then there's the unfortunate story of Erica Smith, a postdoc who in 2018 was sexually assaulted during a Fermilab collaboration meeting. Fermilab officials launched an investigation but eventually concluded they couldn't do anything since neither she nor the person who assaulted her was employed at Fermilab at the time, and the meeting didn't take place on its premises either. The guy wouldn't let go of Smith and, among other things, set up fake social media accounts that portrayed her as a sex worker. She eventually sued him in the UK and reached a £50,000 settlement. The whistleblower report contains the entire story and also explains that there is no happy ending to this testimonial. I left the field in 2023 as the lost productivity through the majority of my postdoc affected my ability to get a permanent position. I've been unemployed for months, trying to recover from all that has happened to me. Smith blames Fermilab management for not doing enough to help her. Another issue that the report goes on about is a stunning increase in the number of accidents in the past years. This clearly looks pretty bad if you look at this graph, but in all fairness, it might just be due to more constructions going on. One particularly bad accident was a construction worker who fell more than 20 feet and spent several months in a hospital. That led to a DOE investigation resulting in a 197-page report, just in case you wonder where your taxes are going. They concluded that the accident could have been avoided. There are a couple of other events in that report that shouldn't have happened, like this one. A subcontractor performed wet saw cutting on the existing asphalt within an established and marked no-dig zone. Or a nearly fatal accident when a diver from a Chicago diving company had been instructed to check a water pump underwater, but it hadn't been turned off. Or this one. On August 25th, 2022, the Fermi Research Alliance reviewed the second quarter radioactive dosimetry results and discovered the worker had received an unplanned dose of 530 milligram, and apparently they're not sure from what or where, which is kind of concerning. Or this one. Cigarettes and cigarette smoke were discovered in a radioactive material area during a highly protective risk inspection, and so on. This all sounds pretty wild, to be honest, but let's put this into perspective. Any large institution will sooner or later see some bad actors and accidents. It's not a question of if, just a question of when. And when that happens, the management has to deal with it. So really, to me, the issue isn't that these things happened in the first place, but that evidently the lab management wasn't able to deal with it and for the most part just did nothing. Well, I certainly hope they'll sort this out. Otherwise, the French will get to joke that Fermilab finally lives up to its name. You've heard of Stonehenge, but have you heard of the American Stonehenge? It was a granite monument built in 1980 that stood in Georgia. It looked indeed a little like the real Stonehenge, with huge granite slabs that reached almost 6 meters in height. The Americans didn't build it just to annoy the Brits, at least I don't think so. The stones had text engraved that, in case of a near-extinction event, would help survivors rebuild civilization. The monument also had helpful physical features like a hole that was directing your gaze to the North Star. A few decades after its construction, conspiracy theorists began to claim that the monument is Satan's work and that its text is really the 10 Commandments of the Antichrist. One of the recommendations on the stones was, for example, balance personal rights with social duties. And I can totally see how one might think this is the work of the Antichrist. On July 6th, 2022, unknown activists bombed down part of the monument. The rest was torn down later with a plan to rebuild it elsewhere, but that never happened. One can debate how useful these stones would have been. If I had to rebuild civilization, then balance personal rights with social duties is not the advice that I've been looking for. But if the story of the American Stonehenge is any indication, then we're not great at protecting our species from extinction. And actually, the biggest problem is other people. A group of scientists is now making a new attempt to save us from extinction, and this time they want to do it on the moon. Yes, on the moon. It's not just because that makes it less likely that conspiracy theorists will blow it up. It's because what they have in mind is the cryopreservation of specimens of plants and animals. They don't want to store the entire animals or plants, but cell samples of them so that the DNA remains intact. Those cells, so the idea, can later be converted into stem cells and the animals be bred in the laboratory to repopulate our planet. Putting such a cryogenic repository on the moon would have two significant advantages. One is that it's already cold up there. The other is that there's no natural disasters, no wars and no climate change. Basically, the samples are safe up there. Having a repository for biological samples is, of course, not a new idea. The Norwegian government, for example, has a big storage for food crop seeds in Spitsbergen. That's a tiny island in the Arctic Circle. The seeds are kept there at freezer temperature, and while they do use a cooling system, the vault was designed so that the seeds would remain safely frozen even if the cooling system fails. You can store seeds there for free, so if you want to back up your favorite marijuana, you just have to find a way to get to Spitsbergen. I know that cruise boats go there because my mum once took such a tour, and she's told me about it approximately 5,000 times.
Pardon me?
Sorry, Mum! I guess this means that if we actually have a near-extinction event, the world will be repopulated by Norwegians. Better get used to putting slashes on your roast then. Though that seems increasingly unlikely because the permafrost surrounding the Norwegian vault is beginning to melt due to climate change. A problem that we wouldn't have on the moon. In contrast to earlier moon ideas, the new proposal would see the repository being built in craters at the poles of the moon. This is because at the poles, sunlight doesn't reach the bottom of the craters. And since the moon has no atmosphere, that means it remains very cool down there, even during the 2 weeks of the lunar day. In those craters, the temperature is permanently below minus 196 degrees Celsius, which is the boiling point of nitrogen. By the way, this video comes with a quiz that lets you check how much you remember. They want to get started with their moon vault by storing samples of species that are already threatened by extinction, and then pollinators and other key species that are important for food chains, like a lot of small fish. The idea has, of course, a few problems. One is that it's expensive to fly to the moon and even more expensive to build stuff up there. But maybe they can offer to cryopreserve Elon Musk's head in return for him saving a few fish. No, the biggest issue isn't the cost. It's that if civilization is destroyed on our planet, then how do we get to the moon? The solution is, of course, to have a permanent settlement on the moon, which, if nothing else, would make for very interesting Olympic Games. What do you think about this? Good idea or a waste of money? Let me know what you think in the comments. The New York Times recently ran an article on climate tipping points. Anthony Watts, a climate change denier associated with the Heartland Institute, wrote a blog post claiming that the entire New York Times article is nothing more than speculation with pretty graphics, and that it heavily hedges its bets with weasel words such as could, may, might, and possibly, but doesn't make a single solid prediction. Let's have a look, shall we? Tipping points are examples of the more general physical phenomenon of hysteresis, which is also known as the path dependence of a system. This means that the current state of the system doesn't just depend on its external variables, for example temperature, at a particular moment, but also on how you got to that moment. An everyday example is chocolate. If you melt chocolate and let it cool down again, it may reach the same temperature that you started from, but the structure be entirely different. I don't just mean the shape, which is now that of your inside pocket. I mean the structure, and also the look of the chocolate will be different. The reason is that it'll have a different crystal structure. It's a similar thing with butter. The state of the system, in this case the chocolate or butter, doesn't just depend on the temperature, but also on what happened on the way to that temperature. The change that happens if temperatures increase will not reverse as temperatures decrease. In the context of climate change, a tipping point likewise refers to a change caused by temperature increase that will not reverse if temperatures decrease. The most obvious example is the melting of glaciers on top of mountains. Because, if temperatures drop, the ice isn't going to crawl back up. Glaciers take thousands of years to form. Yes, if temperatures will consistently remain cold, glaciers will grow again, but not as fast as they went. There are also the massive ice sheets covering land in the Antarctic and Greenland. If those were all to melt, sea levels could rise 50 meters or more by 2300. At that point, much of Florida would be underwater, and for a sightseeing tour in London, you'd hop into red submarines. Besides the sea level rise, the melting of all this ice also greatly reduces the reflectivity of large surface areas, which speeds up warming, so it's a positive feedback. Though a study came just out that says that the major mechanism for a major ice sheet collapse in Antarctica seems implausible, so that's good news. You might not need a submarine for London, a paddle boat will do. Another example of a tipping point is the thawing of the permafrost, that's permanently frozen soil. If it thaws, it'll release potentially large amounts of methane that also contribute to global warming. That's again a positive feedback. And again, the methane isn't going to go back into the ground when temperatures drop. There was also a study on that a few months ago, which found that the methane release would probably not be large enough to itself make a significant contribution to further warming. That is, it'd probably not cause a runaway effect. If it was a runaway effect, that'd mean that the initial release would actually speed up further release. The new study says that this seems unlikely. So this is a second piece of good news today. Then there's the collapse of the ocean circulation in the Atlantic Ocean that I've talked about extensively before because it's constantly being confused with the Gulf Stream. I'm enormously pleased that neither the New York Times nor Watts refer to it as the Gulf Stream. This circulation, known as the Atlantic Meridional Overturning Circulation, drives warm water and with that air to the northern part of the Atlantic Ocean. It's a major contributor to the comparably mild climate in Middle and Northern Europe. Once it shuts down, it might take thousands of years to restart. Anthony Watts claims there's no evidence of that circulation slowing down. He doesn't quite seem to be up to date because the evidence that something isn't right with the AMOC has increased since we last talked about it. There's a very interesting talk by Stefan Rahmsdorf, who used to say that the AMOC collapse was unlikely, but he's now changed his mind. But Watt's major complaint about the New York Times article is that it doesn't make a prediction about exactly when these tipping points are going to be crossed. That's because the predictions for this are extremely difficult. But is this a reason to ignore them? Does anyone really doubt that frozen soil will thaw when it gets warmer, or that ice will melt if temperatures continue to rise? These things will happen if it gets warmer, whether or not we can name a date. It's exactly because we don't know when it'll happen that we should not gamble with further warming. But the scariest part is that climate models don't take into account the social and political feedback. The people who will say, well, what's the point of reducing carbon dioxide emissions if the AMOC has collapsed anyway? We can't undo it, so we might as well not bother. I think that's the tipping point we need to avoid most. The tipping of the public opinion from we can do it to why bother. So keep calm and keep dusting your solar panels. Chinese engineers intentionally interrupted the cooling system of a nuclear reactor to test safety features that are supposed to prevent a core meltdown. It went as desired in the sense that the nuclear reactor didn't blow up. If it had, you'd already have heard about it. But they've now published a paper with their test results. Let's have a look. The major problem with the currently most widely used reactors, pressurized water reactors, is that they require active cooling. You need to pump a coolant, usually water, through them. In the event of a loss of power, the cooling fails, the radioactive fission continues, and the fuel rods get hotter and eventually melt. This is called a core meltdown, and it's generally bad news. For one, it destroys the reactor vessel and radioactive goo leaks all over the place. Worse, the fuel rods are usually coated with zirconium. If that gets too hot, it starts to react with the water and that creates hydrogen gas. It then only takes one spark to blow up the entire reactor building, which is what happened at Fukushima. The new Chinese reactor doesn't have that problem. It has what's called a passive cooling feature. That is, if the power fails, it cools down automatically. The major way that modern reactors do this is with a design that'll make the nuclear fission less efficient if the reactor gets hotter. The Chinese reactor where the test was done is called HDRPM after Elon Musk's 20th son. Just kidding. It stands for High Temperature Reactor with a pebble bed module. The reason it's called a pebble bed is that the fuel isn't as usual in the shape of rods, but rather it's, well, in pebbles, spheres about the size of a tennis ball. They contain enriched uranium with graphite as a moderator. As the pebbles become very hot, the non-radioactive part of the uranium becomes better at absorbing neutrons. But the neutrons drive the fission, so if they get absorbed, that slows down the heat generation. It's called a high temperature reactor because it operates at temperatures between 750 and 950 degrees Celsius or so, whereas the usual reactors run at 300 degrees or so. They use higher temperatures partly because it's more efficient, but also because that way the reactor gets out of the critical zone faster. The Chinese reactors are cooled by helium. Under normal operations, the helium transports off the heat from which energy is created. If the cooling cycle fails, the helium will rise up because it's hot and will be replaced by cooler helium. That is, it'll cool the reactor without the need for any intervention. So first we have a reactor core whose efficiency will decrease if it gets hotter, and then it'll passively be cooled from the gas. The Chinese reactor also uses control rods that require power to be held up. If the power fails, the rods will sink down. That'll reduce the ability of the material surrounding the pebbles to reflect neutrons. Again, that means fewer neutrons, and that slows down the chain reaction. And that's what the Chinese tested. In their report they write, the first test began at 9:16 a.m. August 13th, 2023. The test was started by switching off the power supply of the primary helium circulator and feed water pump. As a result, the reactor protection system was activated, triggering the emergency shutdown signal that induced the dropping of the control rods. The control rods descended by gravity from the top of the core to their lowest position in 70 seconds. You can see in this figure how after the cooling stopped, the temperatures at the top first go up and then down, reaching a stable condition within about 36 hours. The nuclear reactor in China has been tested since 2021 and began operations last year. It has 2 reactors, each capable of generating 105 megawatts of power. The Chinese are very proud of their nuclear reactors, and that's for a good reason, because while some countries have fallen behind, China has pushed the technology forward. But the Americans are catching up. The company Kairos Power just started construction on a new nuclear reactor in the United States that also uses pebble fuel in Oak Ridge, Tennessee. It's a test facility that isn't meant to put power into the grid, called the Hermes reactor. In contrast to the Chinese reactor, the American one isn't cooled by helium but by a fluoride salt, but it has similar safety features. It's scheduled to start operation in 2027. Quite an experiment. I mean, imagine sitting next to a nuclear reactor while it's overheating and waiting to see whether the safety feature will work. Though I'll admit that Core Meltdown Supervisor will look really good on a CV. About 10 years ago or so, when the world woke up to quantum tech, I suffered through a wave of articles claiming that entangled particles can communicate with each other faster than the speed of light, because, they'd say, that's Einstein's spooky action at a distance, and that this could be used to make a lot of money on the stock market by beating even high-speed traders. Then last week, I saw that New Scientist published an article about how quantum tech is going to revolutionize the stock market. I had a look at the paper, and it's both better and worse than I thought. First of all, it's true that stock trades work close to the speed of light limit. I have to admit that the first time I heard about this, I found it hard to believe, but if you think about it, it makes sense. The faster you can collect information and buy and sell based on it, the better your chance of making a profit. If your algorithm predicts that the stock is going to tank, but the algorithms of all other hedge fund managers predict the same, then it matters how quickly you can send information to the next closest stock market. Every microsecond matters. It's like a high-stakes game of musical chairs, but instead of music stopping, it's your retirement savings. Incidentally, I have a friend who told me that since he got fiber optic cables, he has an edge on booking a golfing slot. Same spirit, just without the billions. So high-speed trading is a thing, and some people make a living from it. And that naturally brings up the question of whether Einstein's spooky action can make trading faster. Maybe it can even get you the Sunday afternoon slot at the golf course. Wouldn't that be finally a good reason to build a quantum computer? But what did Einstein mean by spooky action at a distance? Einstein used this phrase in a letter to Bohr to refer to the collapse of the wave function. You might remember that in quantum mechanics, particles can do this strange thing that they can be, for example, in two places at the same time. This is what we call a superposition. Or maybe one could say that the superposition is both strange and not strange, because mathematically it's simply a sum. It's just that it's hard to interpret what it means for a particle to be in one place plus another place. Strange or not, Bohr said that when we measure a particle, the superposition collapses and suddenly the particle is in only one place. It's this collapse that Einstein referred to as spooky action, because it'd indeed be faster than light. The moment you find the particle in one place, you instantaneously know it can't be elsewhere. Einstein disagreed with Bohr. Einstein thought that quantum particles are really only in one place and that the sudden update of the wave function just means that you've learned the particle isn't elsewhere. And his main argument, here it comes, was that by claiming the collapse is a physical process, Bohr was introducing a spooky action at a distance. Even if this spooky action existed, though, it couldn't transfer information. Just because you find out what's going on elsewhere doesn't mean you send information there. John Bell used the following example. When the Queen dies in London, the Prince of Wales becomes instantaneously king. But that doesn't mean Royal Mail goes faster than the speed of light. By the way, this video comes with a quiz that lets you check how much you remember. Einstein's spooky action, unfortunately, is frequently confused with entanglement. Entanglement is a type of superposition, but one in which several particles are correlated. That could be any number of particles, but usually it's two. That they are correlated means they share an unknown property. For example, you may have two particles whose spins, which you can imagine as arrows, must be identical, so they point in the same direction, but you don't know which direction that is. Suppose you create a pair of those entangled particles, send one right and one left. And now the spin values are correlated, but the particles are in different places, so they can't interact anymore. Most importantly, if you do something to one of the pair of entangled particles, that does nothing to the other. Say you turn the spin of the particle on the right side upside down, even though you don't know what it is, then the spin of the other particle doesn't change at all. No, it doesn't. You wouldn't believe how often I see even physicists get this wrong. I just the other day heard a talk from someone who works on quantum computing, for heaven's sake, who said that if you manipulate one of a pair of entangled particles, then that'll non-locally affect the other. No, it'll not. It's just that if you make a measurement on one of the particles, then that'll tell you something about the other, because they're correlated. In our example, imagine you measure the particle on the right and you find that the spin points up. Then you know instantaneously that the spin of the other particle is also up. And we can also see in this example why this can't be used to send information, because the outcome of the measurement is random in any case. You can't predict it. The person who makes a measurement on one end can't tell that a measurement was even done on the other end. So, entanglement is real, we know that. Whether spooky action is real is still a matter of debate, but you can't send information faster than light with either. Now about this new paper. I hope you'll forgive me for thinking that this is what the paper is about, sending information faster than light with entangled particles, which isn't possible. But actually, it's not what the paper's about. They write a lot about high-speed trading, but ultimately what they want to do is to just correlate actions in two places. The example they have is that two people in two different trading places who might want to either both sell or buy at the same time. They might have an advantage from such correlated actions. In the paper, they now say that for this, the trader traders could use entangled particles. You could entangle two particles, send one to the one trader at one stock exchange and the other to the other trader at the other exchange. They'd each measure the particles and base their sell or buy decision on the measurement outcome. Because the particles are correlated, that'd correlate their actions. The authors claim that this gives them a quantum advantage in trading. I strongly doubt that, because you don't need quantum particles to create correlations. If you want correlated decisions at two different places, why not just send signals from a place in the middle? Doesn't even have to be a particularly fast signal. In fact, you don't have to send a signal at all. You could just use synchronized atomic clocks. And this means that if correlating trading decisions is sometimes an advantage, and it probably is, then traders have been doing it for decades. So I'm afraid you won't get rich with it. The real lesson here, I think, is that just because you can add quantum to something doesn't mean that's an improvement. Otherwise, we'd by now all be using quantum toothbrushes. A few months ago, I told you that the near-term future of transportation is hybrid vehicles. This rather predictably pissed off all the Tesla bros who think I don't know what I'm talking about. They're right, of course. I've no idea what I'm talking about or why anyone is listening to me. And yet here you are listening to me. While you're here, let's look at the car sales numbers for Q2. I downloaded this report from PwC, so you don't have to, because they insist on putting you on an email list for this. These are the total sales numbers in the second quarter of this year compared to the previous year. At first sight, that looks pretty good. Hey, all the numbers went up, but hold your confetti. At second sight, you'll notice that the part that increased most is China. If you look at the breakdown for the United States, you can see that there's been basically no increase in battery electric sales, but a significant increase in hybrid sales. Same thing in Europe, where 5 plus 5 means the 5 largest European economies, plus 5 smaller ones sprinkled on top, so that the Americans don't get too confused. Of course, I haven't been the only one to point out that hybrids are a likely development. Ted Nordhaus from the Breakthrough Institute recently wrote about this too, arguing that the most likely shift in the focus of both policy and vehicle production, it seems to me, will be toward various types of gas-electric hybrid vehicles. My main reason for saying a switch to more hybrid is likely was that the infrastructure for electric vehicles isn't coming along quickly enough. And for many people, that means electric vehicles will remain too much of an inconvenience. In case you're wondering how it's going with the electric grid extension in Germany, I just the other day came across this charming graph. It shows the planned new kilometers for electric power lines. The red curve is the original plan, the orange the first revision, the blue the second revision, and the red dots are what actually happened. It's all going just fine. There's also that now that electric vehicles have been around for some while, people are starting to notice that the resale value is poor, which effectively makes them even more expensive. Nordhaus in his article also points out that at least in the US, part of the reason for the stagnation in electric vehicle sales is that the demographic group most likely to buy them is near to being saturated. A study from last year found that in California, electric vehicles are predominantly registered in the wealthiest zip code areas. I haven't seen numbers from Europe, but I suspect that it's a similar thing here. The people I know who have electric vehicles are all house owners that I'd loosely describe as eco-conscious upper middle class. Demographically, it's not the big bulk of people. Another good argument comes from Jesse Jenkins, an expert on energy policy at Princeton University, who argues more specifically that electric motors extended by gasoline are great for, quote, the uniquely American demand for full-size pickups and massive SUVs. Because let's face it, if it can't haul a boat, 3 kids and a small village, is it even American? I'd argue they're also great for the European demand for convenience, because how else do you get the IKEA bed back home? Jenkins writes that he had his insight after learning about the new RAM charger from Stellantis. The RAM charger has 2 electric motors combined with a combustion engine that runs on gasoline and can recharge the batteries. Jenkins writes, "I think it's brilliant," which is basically the same I said about the Nissan Qashqai when I first heard about it. From an engineering perspective, this is an incredibly stupid idea because you have the weight and the troubles of both the battery-powered system and the combustion engine. But then again, from an engineering perspective, we should have been using electric vehicles all along, so maybe not the best argument. I think for the time being, I'll stick by my prediction that we'll see more hybrids in the future until the electric grid upgrade seriously catches up. I base this expectation mainly on reports from the International Energy Agency, which has warned repeatedly that electric grid extensions are lagging behind in most countries. And the most obvious consequence of this, I think, will be to slow down the transition to electric. The second consequence I expect is that in the lack of sufficient grid connections, locally produced energy will look increasingly appealing, especially when it comes to energy-heavy industries. This is going to make small nuclear reactors financially much more attractive. But that's another story and shall be told another time. And as always, I'm not saying that this is what I want to happen or that I think it's good that this happens. It's just what I think is going to happen. If you want more uninformed opinions that you can complain about, don't forget to subscribe. Spoiler alert, there'll be more bad jokes.